Welcome to a geometry video having a look at polygons. Quick rundown of polygons. What characteristics must a polygon have in order to be described as a regular polygon? Well, a regular polygon has all sides and all interior angles equal. So for example, we could have a hexagon with 6 sides. If I could draw a little bit more accurately, I would suggest that if we could put markings on each side to indicate that each of those sides are the same length as each other, we can call that a regular hexagon. If you just had any old random 6-sided figure, 1, 2, 3, 4, 5, 6, good, I can count, that would be a hexagon still, but it wouldn't be a regular hexagon. So a regular hexagon has equal sides and all the angles would be equal as well. You can see that these angles can be different from one another. So that's true of any polygon really. A regular polygon has to have all sides and all angles equal to each other. So unless the markings are there, you can't really call it a regular one unless they've described it as such in words at the beginning of the question. What's the formula to find the angle sum of any polygon? Okay, so we'll need to find the number of sides it's got, and that's one formula to use. The number of sides goes in here, and that S stands for the angle sum. So these are the number of sides, and this is the angle sum here. I'll show you an example in a minute. There's another version of it though, and this is 180 multiplied by the number of sides minus 2. And we'll show you how that works. All you need to know is the number of sides that a polygon has, and you can substitute that number in where the n is and get the angle sum out of it from these formulas. So find the angle sum of an octagon. There's our formula, or one of the versions of it anyway. Now an octagon has 8 sides, so we're going to substitute 8 in wherever there's an n in the formula. So we're going to have 180 outside of 8 minus 2 instead of n minus 2, and that will obviously be 6 there. So 6 lots of 180 we'll be left with, and that gives us a total of 1080 degrees in an octagon. So we're talking about the angle sum of an octagon. I don't think I'll try and quickly draw an octagon, but if you added up all the angles in an octagon, that would equal 1080. Calculate the size of each angle of a regular hexagon. So we're saying it's a regular hexagon. Now we just got through saying that a regular shape, a regular polygon, has the same size angles. So all of the angles are going to be the same size as each other, which is going to help our calculation here. We've got to calculate the size of each interior angle. First of all then, we've got to find out the angle sum of a hexagon. So a hexagon's got 6 sides. So we put a 6 in there instead of the n, and that leaves us with 4 as the result of that bracket. 4 lots of 180. So our formula here, by putting 6 sides in, a hexagon's got 6 sides, and by putting that into our formula, we've found out that the total angles of a hexagon adds up to 720 degrees. Now we also know how many angles we've got. So a hexagon has 6 sides, so the size of each angle, we're going to go angle sum divided by how many angles we've got. If we've got a total angle sum and how many angles we've got, we should be able to do a divide to see the size of each interior angle. So we've got an angle sum of 720 we found, and we know there's 6 angles in a hexagon. We've got 120 degrees for each angle of that regular hexagon. So I can draw a hexagon a bit more quickly, although my last attempt was a bit dodgy. So if that's a regular hexagon, let's assume that I've drawn them the same length as each other, those sides, but still. And I'll just quickly show you what we've done here. We've found the size of each of those interior angles, 120 degrees there. And with a regular one, that's going to be the same size on each of those 6 angles. And that, as a double check, adds up to 720 degrees altogether. So we've found the angle sum using the formula over here. And then we've divided by how many angles we've got to find the size of each. What's the sum of exterior angles of any polygon? This is a strange rule, this one, seriously strange. But the sum of exterior angles of any polygon is 360 degrees. Now, let's check it out for a square. We've got a square there now. What they're talking about with exterior angles, if you extend one of the sides, you get what's created by an exterior angle. That size there, that angle there, that angle there, and that angle there. When they add up, they'll equal 360 degrees. But the strange thing is, this rule works no matter what polygon you have. And even if it's not a regular polygon. Let me switch to blue for this here. If we extend the sides of each of these, and I'll mark the angles in a minute in a different color. If we extend those and we added up all these little exterior angles in what we call a pentagon, a 5-sided figure, that will also add up to 360 degrees. So the more sides you've got, the smaller each of those exterior angles are, but you've got more of them, so it kind of cancels each other out and ends up being a total of 360 degrees if you added up each of those exterior angles, no matter what polygon you're talking about. Really a very interesting rule. Okay, there you have a few polygons and how they work. We had a look at angle sum, we had a look at finding the size of each angle in a regular polygon, and we had a look at that weird rule about the exterior angle of a polygon and the sum of those. Okay, all the best with that, and I'll catch you next time for some more videos.